Hello students, welcome back to the 8th video of this playlist. So this will be the last video of this playlist since in this video we will be solving the last question of January 2024 Mechanics 1 paper. So let's see what's the last question of this paper is about. Okay, so basically the concepts behind this question number 8, it's from connected particles that has been discussed in chapter number 4, that is dynamics, in your mechanics M1 textbook. So in order to be able to solve this question, definitely you should have idea about the concepts that has been discussed in chapter number 4 of your M1 textbook. And also, like I can see in part B, you need some concepts from motion of a particle in a straight line, like the Suvat equations, whatever, like we know about the motion, the variables Suvat. So yeah, let's get started with the last question of this paper, that is question number 8. So right at first you can see a figure, the fifth figure of this question paper. So here a fixed rough plane, it is inclined at an angle alpha to the horizontal. We can see in the figure where tan alpha is 5/12. Okay, fine. A small smooth pulley. Smooth means this pulley don't have any friction. Okay, it is smooth pulley is fixed at the top of the plane. We can see in the figure. One end of a light inextensible string. Light inextensible string is attached to a particle P which is at rest on the plane. Okay, particle P is connected by a light inextensible string to the pulley on its one end. The string passes over the pulley and the other end of the string is attached to a particle Q. You can see in the figure particle Q. Okay, fine, which hangs vertically below the pulley as shown in figure 5. Okay, fine, fair enough. Particle P has mass m. The mass of particle P is given. Particle Q has mass 0.5 m. The string from P to the pulley lies along a line of greatest slope of the plane. Okay, fine. The coefficient of friction between P and the plane is mu. Okay, the coefficient of friction is given. Okay, so the system is in limiting equilibrium. So they wrote this in bold form. That means there's something special with that, right? With the string taut and P is on the point of slipping up the plane. So the system is in limiting equilibrium and the particle P is on the verge of moving what? Up the plane in this direction. Okay, so that's basically the scenario of this question number 8. Okay, so in part A they are asking to find the value of what? The mu. We need to find out the value for the coefficient of friction. Okay, now let's consider the figure. We need to find out the coefficient of friction. So we know that friction always acts opposite to the direction of motion, right? So that means since particle P is on the verge of moving up the plane, that means friction will be acting down the plane. Okay, and friction, since it is on the point of slipping up the plane, it is in limiting equilibrium. So in limiting equilibrium, what we know, that max friction will be maximum, right? And okay, in limiting equilibrium, what we know, that F max is equals to what? F max equals to mu times R. Okay, so we need the normal contact force R, right? We need the normal contact force R here. So let's consider and find the normal contact force R, which is basically perpendicular to the inclined plane. Okay, so weight acts down the plane, downward, vertically downward, and this is the basically the normal contact force. Okay, so at first what we will consider, we will consider the forces perpendicular to the plane. Okay, in this direction. If you consider this direction, then normal contact force R will be equals to the vertical component of weight that I have showed you just now. This is the vertical component of weight. So this is what? This is mg cos alpha, right? This is mg cos alpha. Okay, so 10 alpha is given, there is 5 over 12, so that means cos alpha would be how much? Cos alpha would be it is 5 over 12. This is opposite side over the adjacent, so that means 13. The hypotenuse would be 13, right? So that means it is 12 over 13. Cos alpha is 12 over 13, right? Since the adjacent side is 13, so cos alpha is what? Adjacent side over the hypotenuse. So adjacent side is 12 and 13 is the hypotenuse. Okay, so we got 12 over 13 mg. This is the normal contact force. Okay, now consider particle P only. We will consider P only. It is we will take up the plane as positive. Okay, so if you consider like that, what you can write here, in up the plane, the tension in the string, it is acting, right? Isn't it? Because since the two particles are connected to each other by a string, so they will be always pulling each other, right? So since there will be pulling force acting, we know that whenever there is pulling force acting, there will be tension force will get generated within the string. So tension force is the pulling force. So both the pulley will pull the particle P and the particle P will pull the pulley in this direction. Okay, so that's how the tension force will be acting. Okay, so up the plane on particle P, the tension force is acting. So T minus the weight component, that is mg sine alpha, right? Mg sine alpha equals to what? Resultant force. Resultant force equals to what here? 0, since the system is in rest, isn't it? So that means resultant force is what? 0. Okay, so T minus mg sine alpha, or there's another thing is remaining, the friction. I missed it. The important thing, F max. Okay, F max, it is equals to what? 0, because tension is acting up the plane, down the plane the friction is acting, and yes, and the horizontal component of weight, it is also acting down the plane. So that's how we can write it. So here T is unknown, right? So for finding the T, we will consider particle Q. Okay, if you consider Q only, considering since we took up the plane as positive, so using relation with that, we will take downward as positive for particle Q. Okay, so for particle Q in the downward direction, its weight is acting, right? So this would be 0.5 mg. 0.5 mg minus T equals to what? 0. So tension is what? Tension is 0, half of mg, isn't it? Done. We got the tension. Now just put it there in the previous equation. What you will get? Mg sine alpha. Okay, T is half of mg. We got that. T is half of mg. So what we can write here, T is equals to half of mg minus mg sine alpha, right? So sine alpha is how much? Cos alpha is 12 over 13. So sine alpha would be, the remaining one is what? 5. So 5 over what? 13. Okay, so we got mg sine alpha is 5 over 13 mg, and then we have the friction. We got 12 over 13. Isn't it mu mg? If I'm not wrong, it's mu mg, right? Okay, F max would be what? 12 over 13 mu mg. Okay, I didn't write it, so now I wrote it. 12 over 13 mu mg is the maximum friction. Okay, so 12 over 13 mu mg, this is equals to what? 0. So pretty much simple now. We can cancel out the mg, right? Now take this term to the right. So what you will get? 12 over 13 mu equals to what? Half minus 5 over what? 13. So we need the value for mu. So multiply both sides by 13. You will get what? 13 over 2 minus how much? 5. So mu would be how much? Mu would be 13 over 5 is 6.5 minus 5, that is 3 over 2. So 3 over what? 3 over 2 times 12. That means 3 over 8. The value for mu is 3 over 8. If I'm not wrong, 6.5 minus 5 over 12. This is, sorry, 1 over 8. Yeah, it is 1 over 8. That's the value for the mu. And that's the answer that they have asked for in part A of question number 8. Done. Okay, next is part B. So before part B, they are saying the string breaks and P begins to move down the plane. So P is now moving down the plane. Tension has disappeared. When particle P has traveled a distance of 0.8 meter down the plane, the speed of P is v meter per second. After moving 0.8 meter down the plane, the speed of particle P is v meter per second. Now part B asks to find the value of v. Okay, so we need to find out the value of v. Okay, so initial velocity is what? 0, right? Initial velocity is 0 because the particle P was connected with the string and it was at what? Rest, equilibrium position, rest. Yeah, so after the string has broken, at the moment when the string has broken, initial velocity is 0. After the string has broken, the particle will start to accelerate in the downward direction, right? We know the distance, we know the initial velocity. Just we have to find out the acceleration in order to be able to find out the final velocity v. Okay, so let's consider for part B P only. We will consider for P only, taking downward direction, down the plane as positive. If we take down the plane as positive in downward direction, what is acting? Nothing but the component, the horizontal component of the weight, which is mg sine alpha, right? And what will be opposing the motion? This is the friction, which is F max, right? So F max we got just here. It was 12 over 13 mu mg, right? So 12 over 13 mu mg. We know the value of mu. We will use it definitely. So this is equals to what? Mass times mass of particle P is what? M. So ma. Okay. So m cancels out from both of the sides. So you will get g sine alpha. Sine alpha is basically 5 over 13, right? So 5 over 13 g minus 12 over 13. The value for mu is 1 over 8. 1 over 8 g. This is equals to what? Just a. So we need the acceleration. So let's go for this. Acceleration is 5 over 13 g minus it would be 1 over, not 1, basically it will be 3 over 2. So 3 over 26 g. This is the acceleration. So find out the acceleration. That would be how much? 10 minus 3, that is 7 over, wait, this is 26, right? So this is 10 minus 3, that would give you 7 over 26 g meter per second squared. Done. We got the acceleration, isn't it? So initial velocity is 0 meter per second. We got the initial velocity. We know the acceleration. We know the distance. This is how much? 0.8 meter, right? Is it 0.8 meter? Exactly. This is 0.8 meter. Now we need the value for v. So we need v. So we will use this formula. V square equals to u square. U square is 0. Plus twice of a is 7 over 26 g times s is 0.8. So we need the value for v. V will be how much? Square root of, let's calculate it, 2 times 7 over 26 times 9.8 and then times 0.8. So you will get 1372 over 325. Okay, so this is basically 1372 over what? 325. So if you square root the value, that much meter per second, so if you square root the value, you will get 14 square root of 91 over 65. This is basically in decimal, it is 2.05 meter per second. Okay, it is if I write the exact value, this would be 2.05 46 something. Okay, that much meter per second. You can round it up to 3 significant figures to write it 2.05 meter per second. That's the velocity of the particle P after it has descended along down the plane by how much? 0.8 meter. Okay, so this is the wanted value from the question 8b. Okay, so that was all about question number 8, and this is the last video of this playlist. And if you have any problem in any part of the whole video, in any part of the video, then feel free to comment it below. Definitely I will be there to reply to you. So that's all. Keep yourself fine, and yeah, thank you.